For this next unit of material, we're going to be covering rational expressions and equations. So first I want to define for you what a rational expression is. A rational expression is any expression that can be written in the form of P over Q, where P and Q are both polynomials, but the denominator is not equal to 0. So some examples of this would be something like 1 over x plus 2. That would be an example of a rational expression. Another example, yes, I did that because I want my line to be straight, would be like maybe 2x minus 3 over 2x plus 8. Again, all I'm doing is I'm dividing polynomials. Maybe we have something like 3x over x squared minus 7. Or maybe we even have something crazy like x squared minus 3x minus 4 all over x squared minus 16. So all of these are examples of rational expressions. Okay, so I think I was saying these are examples of rational expressions, and what rational expressions are just two polynomials that are being divided. Now, as a little side note here, not something like x divided by 2, because x divided by 2 is really the same thing as 1/2 x. And so 1/2 x is not a rational expression because all 1/2 x is a term with a coefficient of 1/2, right? And a degree of 1. That's bringing back some stuff, isn't it? So that's not rational. It's actually called linear. That's something you'll learn later on. So that's what a rational expression is. So the first objective up here says find the value of the rational expression given a replacement number. Well, this is going to be a pretty easy concept. So this first example shows what this means. All you do is you substitute the number they give you into the expression. It's just that whenever you do rational expressions, you want to use the order of operations correctly. And so to do that, what I do to be nice and easy and not have to worry about too much is I make sure I calculate the numerator first, and then I calculate the denominator, and then I put them all together. So, -2 minus 2. Everyone subtracts a little differently, but I like to keep and then change the subtraction to addition, and then I'm going to change that 2 to -2. So I do a process called keep, change, change. So with the keep, change, change, I now see that I'm adding 2 negatives. And to add 2 negatives, you simply add and keep the sign. So that's not too bad. So that's the numerator. The denominator, I really don't have to do anything with. I'm just rewriting it to see that I'm still adding 2 negatives, so I add and keep the sign. And -4 divided by -7 is just 4 over 7, because those have no common factors, but 2 negatives divided make a positive. So 2 negatives added make a bigger negative, but 2 negatives multiplied or divided, that's what makes a positive. And when you go and you look at that first homework, number 10, these first group of problems here, this is going to be just like this example. So you've got x here, and you're going to plug in 3 for these, and then you have y equals 2, and that's going to go into these. I don't know why it's letting me write on here. That's weird. I'm just going to roll with it. Okay. Well, let me erase. Okay, I'm making a video. Let's go back. Anyways, so that's pretty cool. So that's the first objective. Make sure you can substitute in and perform the order of operations to calculate a value. Now if I go back up here, let's look at this next objective. Identify values for which a rational expression is undefined. Well, let's see. There's a sentence here that says in the previous example, which is this one, it says, what would happen if we tried to evaluate the rational expression for the number 5. So if I were to come in here, oh, it wouldn't let me take the whole thing. If I were to come in here and instead of plugging in -2, if I were to plug in 5, let's see. So this one I don't have to do much with because the numerator 5 minus 2 is just 3, and the denominator would be -5 plus 5, which is 0. And there's a big problem with that because we cannot divide by 0. So recall that if you have, it's okay to have 0 in the numerator. So if I had 0 divided by 3, that would be okay. It would just equal 0. But it's a no to have 0 in the denominator. So 3 divided by 0 is a no. Both of these are undefined. So okay to have 0 on the top, not okay, no to have 0 on the bottom. And so plugging in 5 would not work because there's no way that we can divide by 0. And so one thing that you're going to want to do in algebra is be able to know when you're going to have undefined, you're going to want to know what values are going to give you undefined in rational expressions. And so looking at these next examples, it says a rational expression is undefined when the denominator is equal to 0. The sentence I just highlighted has the word numerator nowhere in it. The numerator being 0 is okay, right? Literally what I just said up here, okay. It's only that denominator that is a no. And so when you're asked a question about a rational expression being undefined, what that means is you're going to look at the denominator. So here my denominator is x plus 8, and I need to find out where that equals 0, because wherever that equals 0, that expression is not going to work. And so if I solve this, I get x equals -8. And so the answer to my question, are there any values of x for which each rational expression is undefined, which really is this and this one. It's kind of confusing looking. But the answer to this first one is yes, and the answer is -8. Yes, there is a value, and it's -8. I've got another one here. For this one, again, I don't care about the numerator for this undefined question. Undefined, I only worry about the denominator. Again, look at what's highlighted up there. So that means I'm going to look at 15x plus 45 and figure out where it equals 0. Well, this is just a two-step equation. So I'm going to do 15x, I'm going to subtract my 45, and then I'm going to divide by 15. And so I get out of this -3. So again, yes, and the answer is -3 for that one. And so on the homework for this unit, or this section, I'm sorry, that is going to be working with these right here. Find any real number for which it's undefined. So you're just going to be setting these to 0. Ooh, you can't set 19 to 0. So if you can't set 19 to 0, that means this denominator will never be 0. So the answer for that one's probably none. So that might be a helpful little hint. Okay, so let's look at the next little topic we got going on here. The next objective says to simplify or write a rational expression in lowest terms. And simplifying a rational expression is basically the same as simplifying a fraction. You know, if you had a fraction to simplify, if you were asked to simplify, let's say 18 divided by 42, a lot of students were taught to find the greatest common factor and divide it out, or just start dividing out what they have in common. But one option would be to factor the top and factor the bottom. In fact, prime factorization is really the best. But if you can't do prime factorization immediately, just start off by any factorization. Meaning that I'm going to think of any way that I can break 18 down into two numbers multiplied together. The only thing I don't care about is 1 times 18. But I've got a couple of options here. I could do 2 times 9 or I could do 3 times 6. It doesn't matter which one you do. Now, out of these numbers, is there any I can break down? Yeah, I can break down 9 into 3 times 3. So that numerator actually breaks down into 2 times 3 times 3. Okay, so now let's look at the denominator, 42. The two that people have said right off the bat are 2 times 21 or 6 times 7. So let's say you did 6 times 7. Well, 7, I can't do anything with that, but can I break down 6 into 2 times 3? And now notice that all the numbers I have cannot be broken down any further. And because of the fact that when we see something like this, we are allowed to write it like this. We are allowed to break this up. And so 2 over 2 is 1, 3 over 3 is 1, and 3 over 7 is 3 over 7. But what most students do at this point is they simply come in here and realize that, oh, that can be canceled to a 1, this could be canceled to a 1, and so the only numbers I have left are 3 over 7. So this is a nice way to simplify fractions. And the reason why I like to show this is because what I did was I factored the numerator, I factored the top, and then I factored the denominator, right? I factored the bottom, and then I canceled out common factors. This is the exact same strategy you use, in a sense, to simplify rational expressions. The only difference is it's more complicated factoring because you have variables. But all of that stuff we did before the midterm, all of that factoring techniques, that's where these are going to come in handy now. So, to simplify rational expressions, it says completely factor the numerator and denominator, and then divide out common factors. So, when I look at this, my first step here is that I'm going to want to figure out, is there anything I can factor with 7x plus 35? And so remember, with my factoring flow chart, I always want to do GCF first. And then it's based on whether there's 2, 3, or 4 terms. If there's 2 terms, is it difference of squares? If there's 3 terms, it's Diamond or Claudia. And if there's 4 terms, it's grouping. If you didn't get the factoring flow chart, I think it was in one of the emails I sent with the notes. It's at the end of one set of the notes I sent. But if I look, 7x plus 35, right? Remember, I'm thinking, is there any number I can remove? And yeah, it would be 7, right? And so what I would be left with is x plus 5. So I'm going to write 7 times x plus 5. You know, there's a great temptation when you see something like this to want to start like, oh, I can take out an x and 5 and 7. No, you cannot cancel across addition. I shouldn't have even written that down. We have to factor because we can only cancel across multiplication. Now let's look at the denominator. X squared plus 5x. Well, what do these two things have in common? Well, an x. So if I take out x, I'm left with x plus 5. So this denominator becomes x times x plus 5. And so now, because I have the same factor, x plus 5 in the top and the bottom, I can cancel them out. Which here, when we say divide out or cancel, we mean, you know, anything divided by anything, or I shouldn't say that, anything divided by itself is 1, right? And so that's what I'm going to do here. And so all I'm doing right now, though, is I'm just going to recopy what I wrote so that we can see what I'm doing. This is really a 1. And so all I'm left with here is 7 over x. Can't do anything with that. I'm just done. But that's the strategy. Factor the numerator, factor the denominator, and then find your, or cancel your common, divide out your common factors. All right. Example 5. So when I see this example, there's no GCF on the top, right? I just have x squared plus 3x minus 4. So it's got 3 terms, and there's an understood 1 right there, which is awesome. Because if it's 3 terms, and it's x squared, and a number times x, and a constant, then all I have to do is my little diamond technique, where I say, what 2 numbers multiply to -4, I go ahead and put that there, and add up to 3. Well, your options are 1 and -4, -1 and 4, 2 and -2. Or that's the same thing. So these add up to 0. This adds up to -3, but there adds up to +3. So after quickly going through all my options, I get that -1 and +4. Oops. So I can break this apart into x minus 1 times x plus 4. All right, now I'm going to do the same thing with the numerator, x squared minus x minus 20. So I'm going to go ahead and do my x's. And remember, this is an understood 1. So I'm looking for two numbers that multiply to -20 and add up to -1. Well, 1 and -20 or -1 and 20? Absolutely not. So, 2 and -10 add up to -8. -2 and +10 add up to 8. And by the way, that added up to those. So 3 doesn't work. 4 and -5 add up to -1. So those are my numbers, 4 and -5. I'm going to go ahead because I'm looking ahead, and I'm going to put the -5 first so that when I write my factors, do you see that I've got the same thing in the numerator and denominator? And I've already lined it up. So at this point, you could cancel these out, and you would be left with x minus 1 over x minus 5. So you would just simply say, and by the way, guys, I'm just rewriting or recopying this down so we can actually see that process of, hey, I'm dividing these out to a 1, understood 1, and that's just going to leave me with x minus 1 over x minus 5. And it's very tempting, again, for students to want to do something like that, but you cannot cancel across addition or subtraction. I was able to cancel here because I changed it into multiplication. For example, if x happened to be 7, like if you look at this, 7 minus 1 over 7 minus 5, you can't cancel those 7's out and get -1 over -5, which is a fifth. That's just crazy. Because 7 minus 1 is 6, and 7 minus 5 is 2, and 6 divided by 2 is 3. So that's why you just can't cancel across addition and subtraction, because there's no way to know how it's going to work out. But if I had 7 times 1 over 7 times 5, then I can cancel that out, because that would be 1/5. Because even if I did multiply it out, I would get 7 over 35, which again reduces to 1/5. So that would work, but it's only because I changed it to multiplication. So remember that. It has to be factored before I can cancel out common factors. Let's see. So when I look at this one immediately, x plus 5, nothing I can do with that. X squared minus 25 is a binomial, and there's no GCF. So you want to think difference of squares. Difference of squares was simply the ability to factor a number squared or something squared minus something else squared into the sum of what's being squared times the difference of what's being squared. So when I see x squared minus 25, is there any way to write this as the difference of two squares? Yes. X is being squared and 5 is being squared. And so now I'm going to take x and 5 and add them, and then x and 5 and subtract them. And so that's how I would factor that denominator. So now I'm going to come in here, and my common factor is x plus 5. And so a lot of times students want to cancel these out and think there's nothing left. But remember, it's a 1, right? Anything divided by itself is 1. So what we're left with in the numerator is a... it's not working. Oh, no, it's doing that thing again. What I'm left with in the numerator is 1 and x minus 5 in the denominator. And that's as far as I can go. Just as a little side note, because I think this is nice to see, if you had had something like, let's say, x minus 2 over x plus 2 divided by x minus 2, whenever you cancel here and get a 1, then you would just be left with x plus 2. Because in here it's really over 1, but you're not going to write that. So that's something that I want you to notice. If you're dividing by 1, you just write it as x plus 2. If you are dividing into 1, like this one, you have to write the 1. All right, example 7. This is an important concept. On example 7, it would be so awesome if I could just turn that around and make it y minus 7. But I can't do that because that's not addition. If it were addition, if it were something like 3 plus a over a plus 3, well, that's perfectly okay to do, right? Because addition is commutative, meaning you can reverse the order. And then you get something divided by itself is 1. But you can't do that with subtraction, right? 7 minus 10 is not the same as 10 minus 7. They're close, though, because this is negative 3 and this is positive 3. So if I wanted to make the adjustment, if I wanted to make 7 minus 10 somehow come out as positive 3, then I would just have to multiply it by negative 1. Ooh, that's a cool little trick. Yeah. So, and that's supposed to be a negative 1. It looks horrible. So if I were to multiply by negative 1, I can then reverse the order of the subtraction, because that would now be negative 1 times oh, I just did that weird. I didn't mean to change that. That would now equal 3, because negative 1 times 3 is negative 1 times negative 3 is 3. So that's kind of weird. It's kind of a weird concept, but it is just a fact. If you want to memorize it, it is a fact that I want to see what letters I want to use. N minus m is the same thing as negative m minus n. So you can change the order of subtraction if you factor out a negative 1. So what I would do on this example is I would take 7 minus y, and by factor out a negative 1, I simply mean pull the negative, divide out a negative 1, so that would become negative 7 plus y, right? Because dividing by negative 1 is going to switch those signs. And then I've got negative 7 plus y. Well, that's addition now, and with addition, I can reverse it and say that's y plus negative 7. Which is really what? That's really y minus 7. And so that's what I can do here. So on this one, I'm going to rewrite the numerator as negative 1 times y minus 7. And so now my y minus 7's divide out. So I have negative 1. And when I say divide out, these equal 1. And so negative 1 times negative 1 is negative 1. And there we go. And so they like doing this in the homework. Look at 9 and 10 here. 9 is addition, so you should be easy on that. But number 10 is exactly like the example I just did. In fact, I think that's the only one there. Okay. Last one for this homework. So, the last example I have here, let's see. The numerator is 4 minus x squared. Well, 4 minus x squared is the same thing as 2 squared minus x squared. And so we just saw a second ago that we can break that into the sum of what I'm squaring, which would be 2 plus x, times the difference of what I'm squaring, which would be 2 minus x. So this numerator becomes 2 plus x and 2 minus x. Two plus x, you can turn 2 plus x around. You can make that x plus 2, but you can't just turn that one around. So hold your horses. All right, the denominator, 3x squared minus 5x minus 2. Well, this is not just a straight up diamond because of the 3. Because of the 3, this is Claudia's technique. And Claudia, whoever she is, says that we can kind of think of it like a diamond by tricking it for just a second and multiplying by 3 with the last number. So Claudia says you can trick this for just a minute by dropping the 3 away by multiplying it with the last number, so that now I get x squared minus 5x minus 6. And so for just a second, I can trick it to figure out some numbers. So my numbers I'm trying to figure out, oh my gosh, sorry y'all, are negative 6 and negative 5. So your options are these two numbers, these two numbers, these two numbers, or these two numbers. And these add up to 5. This adds up to, I'm working down here, 1. This adds up to negative 1. But this one adds up to negative 5. So negative 6 and positive 1. So we can break this down into x plus 1, x minus 6. Again, not the final answer though, because that was the answer to this. What I now have to do is I have to come and divide out that 3 that I used to make it easier to find my numbers. And so once I set up the division, a couple of things could happen. One thing is 1/3 is a fraction. It's fully reduced. So if my fraction is fully reduced, I'm going to bring that that denominator, that number in the denominator up in front of the variable and write it as 3x plus 1. You could also have something like 6 divided by 3, which is just a nice x minus 2. And so now I've got it factored. So now I can come up here and write 3x plus 1, x minus 2. Now I'm looking for common factors. Well, the closest thing I see is this and this. But I need to turn the top one around. So here's what I'm going to do. Because it looks better, I'm going to do this. I'm going to take this and I'm going to turn it around and make it x minus 2, but I have to remove a negative 1 in order to do that. So again, check it out. What's negative 1 times x? Well, that would be a minus or negative x. What's negative 1 times the negative 2? That's positive 2. So I haven't changed anything in terms of its value. I've just changed how it looks. And then that's 2 plus x. Oh my gosh. 2 plus x, 3x plus 1 over x minus 2. So now I'm allowed to cancel. Now I'm allowed to say I just have negative 1, 2 plus x over 3x plus 1. Now, what I'm going to do, guys, is I'm going to switch these because usually I like to do x plus 2. And so now I'm going to talk about the last objective in this section. So take a righty with me here. Whoop. Nope, too far. And that is this last objective that says write an equivalent rational expression in the form negative a over b, which is the same as negative a over b, which is the same as a over negative b. Meaning, when you divide two values, if you divide a negative by a positive, or if you divide a positive by a negative, you are going to get a negative. That's all that's saying. So when you see the negative in front of a fraction, it doesn't mean they're both negative, because if both those were negative, we just saw that a negative divided by a negative was a positive. And so when you have either the numerator or the denominator negative, but not the other one, then you can make that a negative fraction. Or if you have the negative in front of a fraction, you can put it with the top only or the bottom only. So when I saw this problem down here that we just did, what I would do on this answer is I would write it as negative x plus 2 over 3x plus 1. But you could have also written it as negative x minus 2 over 3x plus 1, or x plus 2 over negative 3x minus 1. Meaning I could have distributed the negative here and gotten negative x minus 2, or I could have moved it down here and distributed it down there and gotten negative 3x minus 1. But you can't do both. You have to choose one or the other. Personally, this is my preferred way of writing a negative fraction. It just looks a little bit better. And so this one was kind of easy because everything was positive inside, in here and here. So just as a side note to kind of help you with the last problem on the homework, number 16. With number 16, what you want to do is something like this. It says to write equivalent expressions to, and actually I need to look at it again. How many does it say? List 4 equivalent forms of the rational expression. Wow, 4. So let's say I had x minus 5 over x plus 2. Well, I could multiply the numerator by negative 1 and get this. That's one option. Or I could multiply the denominator by negative 1, leaving the numerator alone, and I would get negative x minus 2. So that's 2 equivalent ways. I could also take and write it as 5 minus x over x plus 2. So I just took that and turned it around. That's an option. Or you could turn the denominator around. You can turn them both around if you wanted to. But you could take x minus 5 and then do negative 2 minus x. There's a couple of ways you can write it, but those are the 2 fundamental ones that you would start with. Also, if you don't, you could also do a situation where you do this and you do that and do negative 5 plus x, right, leaving the negative sign in front. But you definitely want to do the 2 options where you either distribute the negative to the top or you distribute the negative to the bottom. So definitely do those 2. And then from there, it's just your options are just switching the order in the top and or bottom. So that's what you're going to do. And then you'll have your homework done. So I showed you how to plug in numbers, how to find undefined values, and then these are all just simplify. Factor top and bottom, cancel common factors. And then the last one, you're good. So you're good to go.